All right, let's look at the homework 7.9, problem number 5. All right, so we want to use a double integral to find the volume of this solid here. All right, so let's do that. All right, so first thing I would do is I'm going to rewrite this surface equation here, and I just solve for z. All right, so first thing I would do is let's say subtract x squared. So we have z squared is equal to 49 minus x squared, right? And then we take the square root of both sides. So you get z is equal to plus or minus square root of 49 minus x squared, right? So the surface we're looking at is above the xy plane, so we definitely take the positive one. So we're going to use the positive version of that. All right, so this is it. All right, so let's set up the integral. So the volume V is equal to, all right, so we have a double integral. All right, so integrand is square root of 49 minus x squared, right? And I'm going to actually try to do it the integration with respect to y first, then with respect to x, right? So for fixed x value, so let's say fixed x value, and you can see that the y equals 0 is the starting point, and all the way up to y equals x. So we know that the lower bound is 0 and upper bound is x, right? Then in order to cover the entire triangular base, you can see that here, starting from x equals 0, then x is going to go all the way to x equals 7. So it goes from 0 to 7. Right? Then let's evaluate this guy. So this is going to be equal to, so integral from 0 to 7. So this is just the left alone. Right? And here, since we have, this is integration with respect to y, so there's no y in there. This is just a constant. So we can actually place it outside. Right? So you have a square root of 49 minus x squared, right? So this is going to be just an antiderivative 1 with respect to y, so it's going to be just y, and going from 0 to x, right? So if you plug in x, you're going to get x minus 0, so this is just going to be x, right? So for this one, I'm going to use the substitution. I'm going to let u be this guy right here. So expression inside the square root. So this is my u. All right, so it's a 49 minus x squared. All right, so if you take the derivative of u with respect to x, you're going to get negative 2x. And then take the reciprocal of both sides. You get dx over du, which is equal to 1 over minus 2x. Then we can multiply by du, so that the dx is equal to du over negative 2x. Right? And also this is a definite integral, so x is going from 0 to 7. And if you convert it to u value, you're going to get, if you plug in 0, you get 49. And 2, if you plug in 7, 49 minus 49, 0. Right? So this integral becomes integral from 49 to 0. And this is square root of u and I'll leave x as it is. Dx is du over negative 2x. Right? So we can cancel x on top and x on the bottom. Right? And I'm going to actually use the negative sign here to switch the lower bound and upper bound. So I'm going to go from 0 to 49. Right? Then we still have 1 over 2. So I'll probably place it outside. Right? So you're gonna get a 1/2 is outside. Right? Then you have an integral from 0 to 49. And I don't like square roots, so I'm gonna write it as a 1/2 power. And then we have a du. Right? Then we have 1/2. Antiderivative would be add 1 to the power, so it's going to be 1/2 plus 1 is 3/2. Divide by 3/2 is equivalent to multiply by 2/3. And then you're going from 0 to 49. Right? So let's see, we can cancel 2 and 2, and so 1/3 is just going to be a number, so it's a 1/3, just to pull it out. And then if you plug in 49, let's see, 49 to the 1/2 power would be 7, because it's a square root. And 7 to the, so this is going to be just a 7 cubed, right? So what's 7 cubed? Let's see, 7 times 7 is 49, and times 7. 7 times 9 is 63. So 4 times 7 is 28. So it's a 34, right? So this is 343 over 3, right? So let's type it in. 343 over 3, right? Let's check the answer. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.